Alright, so I'm going to start on this document cam right here by rewriting some of the key information that we need to answer this question. And I'll rewrite the question as well. Alright, so we're saying that we have the length of a trial as a normally distributed variable with a mean of 4.2 days and a standard deviation of 0.9 days. So we know that this variable would look like this if we drew it out. We've got length of trial in days, and it's normally distributed, so we've got this symmetrical bell shape, my art skills aside, with a mean of 4.2 days and a standard deviation of 0.9 days. So I've just drawn out the variable, and this tells us that we know, an average trial is going to last about 4.2 days. It's unlikely it's going to be much longer than 4.2 days. It's unlikely it's going to be much shorter than 4.2 days. So the first part of the question asks us to find the z-scores for the following numbers of days, 3 days and 7 days. So z-scores for 3 days and z-scores for 7 days. To find the z-scores, we'll use our z-score formula. Our z-score formula I'll also write out here. So to find z-scores, we use the formula of z is equal to x, which is your value of interest. So 3 days would be an x, 7 days could get plugged in there as well. Then we subtract our population mean and divide by our population standard deviation. So here our population mean, this Greek letter mu, is corresponding to our population mean of 4.2, and our population standard deviation of sigma corresponds to our population standard deviation here of 0.9. So again, recap from last week, what this z-score will allow us to do will be to tell us how far off from our population mean are each of these values. So 3 days, we can see is going to be on the left side of this because it's in a more negative direction than relative to 4.2. So we can say, we've got a trial lasting 3 days. That's one of our x's. And how far away from our mean are we going in a negative direction? We can do the same thing with 7 days. So here we've got x equals 7. And the question that we can answer when we look at z-scores will be how far off from this mean are we in a positive direction. And when we're counting in z-scores, as you guys remember from last week, we're counting in standard deviation units. So our question is, how many standard deviations away from the mean are we at 3 days or 7 days? We can also redraw this as a standardized distribution. So here we say if we count everything in z-scores, we're going to keep everything about our drawing the same. The only difference is that now we're going to be counting in z-scores instead of counting in days as our units. So it's like converting from feet to inches. We keep everything else the same, but now we're counting in z-scores instead of days. And so when we standardize, we're always going to have a mean of 0. And then we'll say that we're some number of z-scores away from the mean in either direction. Again, but we're keeping everything else about our distribution the same. But we have a mean of 0 and a standard deviation of 1 after we've standardized it. So this is still the setup for the problem here. So we have a standard normal distribution here that is exactly the same as this other one. So in setting up the problem, what I've done is I've drawn out everything we know about our distribution. So we know we have a mean of 4.2, a standard deviation of 0.9, and we're interested in these two possible lengths of days trials that we could have. So a 3-day trial or a 7-day trial. And we're going to be interested in the probabilities of outcomes related to, a 3-day versus a 7-day trial. So I've drawn all this on our normally distributed variable. So this is a probability distribution, again, showing the probabilities of getting different numbers of days. And I've also gone ahead and I've drawn this as a standardized distribution as well. And to do that, I kept every single thing the same, except I converted everything to z-scores as units. So instead of counting in days, we're counting in z-scores, where your z-score tells you how many standard deviations away from the mean you are. And in our standardized distribution, I have a mean of 0, and I have a standard deviation of 1. That's going to be the case for every standard normal distribution that you ever see, ever make. And what I'll be looking for will be the z-scores that correspond to 3 days and 7 days here, because I don't know them yet. So that's where this z-score formula comes in. So now we're getting to actually answering the question. So I promised that once I started actually answering the question, it was going to be pretty quick. So that was, again, the setup, the recap, the background information that we're going to need to know to answer this question. But now that we're getting started, it's going to take just a couple of steps to get an answer. So our first question here is going to be, what are the z-scores for these different values? So we've defined z-scores, now we can just find them. So for 3 days, we're going to plug what we need to plug into the equation. X is our value of interest, so that's 3. Mu is our population mean, so that's 4.2. And sigma is our population standard deviation, so that's 0.9. So now we have an equation here. We can do this math and come out with a number. And if we subtract 3 minus 4.2 and divide it by 0.9, the answer that we're going to come up with is negative 1.33. I'll box this off here because it's getting in my way. But we've got a z-score of negative 1.33 for this 3-day trial. And that tells us that we are 1.33 standard deviations away from the mean, going in a negative direction. And so we can plug this in here. This is 1.33, and it's negative. And that tells us that we've gone 1.33 standard deviations away from the mean in a negative direction to reach 3. We'll do the same thing for our 7-day trial. So here we can plug stuff in. So we've got a value of 7 for x, that's our value of interest. We're going to subtract 4.2, that's our population mean. And we're going to divide by 0.9, because that's our population standard deviation. So if we do this, 7 minus 4.2 divided by 0.9 will come out with a z-score of 3.11. And what this tells us is that if you start at 4.2, you have to do 3.11 standard deviation jumps in order to get out to 7. So we've got a z-score here of 3.11. Again, that tells us that we're going out 1, 2, 3, and then a little bit more standard deviations before we hit this value of 7. So now we have our 2 normal distributions. They're exactly the same, except in this one we're counting in days, and in this one we're counting in z-scores. So we've got our 2 observations of interest at 3 and 7, and now we have z-scores for those. That tells us that we're at negative 1.33 standard deviations away from the mean in a negative direction for this value of 3. And we are 3.11 standard deviations away from the mean in this direction for this value of 7. All right, so that was the first part of the activity there. The second part, and this is where it got a little trickier yesterday, was using these z-scores to figure out different probabilities. And in the activity on the PowerPoint, I asked for 3 different probabilities. And the 3 probabilities that I ask about are in ranges. And the ranges are 4.2 to 7 days, 3 to 4.2 days, and 3 to 7 days. So what are the probabilities that, in this court, where this is how trial lengths are distributed, what are the probabilities that a trial is going to last between 4.2 and 7 days, that it's going to last between 3 and 4.2 days, or that it's going to last between 3 and 7 days? And to answer this question, we're going to use the area under the curve. So you remember from last week, we could find the probabilities of getting outcomes within 1, 2, and 3 standard deviations away from the mean by looking at the area under the curve within 1, 2, and 3 standard deviations of the mean. And the same concept is going to apply here, except when we look at the probability of getting an outcome between 4.2 and 7 days, we're going to be interested in the area under the curve between 4.2 and 7 days. So I've shaded in that area under the curve that we're interested in. Once we figure out this area under the curve, we're going to have our answer, because the area under the curve between these two values is going to be equal to the probability of getting an outcome between those two values. And to do this, we're going to use the fact that these two distributions are completely identical in every way except the units we're counting in. So I can shade in this area here. This is my area under the curve between a z-score of 0 and a z-score of 3.11. A z-score of 0 corresponds to our mean of 4.2. A z-score of 3.11 corresponds to my z-score of 7. So everything about this is exactly the same, except that in this one I'm counting in z-scores, so it goes from 0 to 3.11 instead of days, because when I counted in days it went from 4.2 to 7. But like converting from feet to inches, we have different numbers, but everything else about it is exactly the same. And because our standard normal distribution is the same every time, we can find probabilities for the area under the curve using a reference guide. And the standard normal table is a reference guide that tells us what's the area under the curve between the mean and a particular z-score on the table. So as you can see here, this drawing on the top of the table looks more or less like this drawing I have right here. So we've got a normal distribution, we've got some shaded area under the curve, starts at 0 and goes out to a z-score. So what this table will let us do is it'll let us look up the area under the curve between the mean and our z-score of interest. In this case, our z-score of interest is 3.11. So to look that up, I'm going to use my z-table. As you guys remember from whatever day that was last week, probably Thursday, you can look up z-scores on the table by looking up your digits on there. So you've got our first two digits of our z-score are 3.1, and our third digit here is a 1. So we're going to look at 3.1, and then we're going to look at 0.01 on the table. So to find this area under the curve, sorry, I'm losing my papers. To find this area under the curve here, we're again going to use the z-score, and we're going to look it up on this reference table that tells us what area under the curve you can find in between the mean and any z-score we might be interested in. So here we're going to go down to 3.1. See, 3.1, that's our first two digits of our z-score. And our third digit is a 1, so we're going to go over here. And where these two things intersect is going to be our answer. So they intersect at this value here, which is 0.4991. So what this tells us is that, according to this table, if you have a standard normal distribution, you're always going to find an area under the curve between the mean and a particular z-score of 0.4991 when that z-score is 3.11. In other words, stated again, we found the area under the curve that's shaded here. And we did that by looking it up on the table with our z-score of 3.11. So this tells us that on our standard normal distribution, our area under the curve is equal to 0.4991. So notice I didn't calculate anything, I just looked up my z-score on the table to find this answer. So now we know that our area under the curve is 0.4991 on our standard normal distribution. Since everything is the same in these two distributions except the units we're counting in, we know that our shaded area under the curve in this one is also 0.4991. So everything is identical, the lines are all in exactly the same places, the only thing that's different are the units we're counting in. But the units we're counting in don't matter when we're looking at area under the curve, because here we're just interested in the literal area, the shape of this distribution that's shaded in here under the curve. So if this one is 0.4991, according to our reference table that applies to every standardized normal distribution, we know it's also going to be exactly the same here, and it's going to be 0.4991. The probability of getting an outcome between two values is equal to the area under the curve between those two values. The area under the curve between 4.2 and 7 is equal to 0.4991. So that is our answer. So what we did here to get this answer was we drew this out, we figured out what portion of the area under the curve was going to be shaded, and then we looked up that area under the curve on the standard normal distribution using z-scores. Once we found the answer, though, we didn't have anything else to calculate, anything else to do, because this 0.4991 area is equal to this 0.4991 area, and this area here is equal to our probability. So the probability of getting an outcome between these values is equal to the shaded area, and that shaded area is 0.4991. So we can say we have a 49.91% chance, or a probability of 0.4991, that our trial is going to last between 4.2 and 7 days. All right, so that was our first example there. And that one still involved a bit of explaining things and recapping along the way. For this next one, I'm going to do it even snappier than that. So for our second probability we're interested in the probability of a trial lasting between 3 days and 4.2 days. So what's the probability that in this particular court a trial is going to last between 3 days and 4.2 days? Our probability is going to be equal to the shaded area under the curve in between 3 days and 4.2 days on our normal distribution. So now I've got these sideways zigzag lines that tell us that we're interested in this area under the curve here. Once we find this area under the curve, we're going to have our probability, because that area under the curve is going to be equal to the probability we're interested in. To do that, we're going to shade in the same area on our normal distribution, our standard normal distribution. I distracted myself by drawing the lines in the other direction by mistake. But we're going to shade in the same exact area on our standard normal distribution, and we're going to look that up. So we want to find this area here with our diagonal lines, and we're going to do that by looking up the equivalent area under the curve on the standard normal distribution. Why? Because these two areas are going to be exactly the same as each other. So I'm going to come back to my normal table. I'm interested in finding the area under the curve between 3 and 4.2 days. Since this area under the curve is going to be exactly equal to this area under the curve, I can use my standard normal distribution table to look up the answer. So I've got a z-score of negative 1.33 corresponding to my value of 3 days. And so I'm going to look up the area under the curve between 0 and negative 1.33 on the table. There are no negative numbers on my z-table, so what I'm going to do is just ignore that negative sign and look up the area under the curve for 1.33. So in the column, I'll look up 1.3, and in the row, I'll go over to 0.03. So we've got 1.33 as our z-score of interest, so 0 to negative 1.33. And we're going to look up 1.3 and 0.03 on the table. So to find this area under the curve on the standard normal distribution that we're interested in, we're going to go down to 1.3 and over to 0.03 and see where these numbers intersect. And they intersect at a value of 0.4082. So this tells me that my area under the curve with diagonal lines is 0.4082. So this area under the curve here is 0.4082. That means that this area under the curve is also 0.4082. And because the area under the curve between my values I'm interested in is equal to the probability of getting an outcome between those values, my answer to this question is also going to be 0.4082. So the probability of a trial lasting between 3 and 4.2 days is going to be equal to 0.4082 if we're counting as a probability from 0 to 1. And we could also restate that as 40.82%. So we found our z-scores for 3 and 7. We used them to figure out how far down these lines would be on our standard normal distribution. And then we were able to look up the area under the curve on the standard normal distribution between our values of interest in order to find out the area under the curve between those values of interest on our original distribution. So here we have a probability of 0.4082 or 40.82% of getting an outcome between 3 and 4.2 days. So how about this last question here? So we had 3 and 4.2 days. But our last question asks us, what's the probability of getting an outcome between 3 and 7 days? And so one thing you note on the normal distribution and the standard normal distribution in the z-table is that if we're looking things up on the z-table, we are stuck looking at values that are between the mean and some other value. But nothing can stop us from doing that twice and then adding those together. So what we can do here is we can treat this normal distribution as a shape with an area where areas can be added together. Just like if you had two squares with different areas, you could add those areas together to find the total area of your two squares. And here, if we're interested in the probability of a trial lasting between 3 days and 7 days, we're interested in the total area under the curve between 3 days and 7 days. So here I'm going to just draw a thicker outline around this total area under the curve that we're interested in. So we got a total area under the curve between 3 days and 7 days, and that's the total area that we need to find in order to answer this question. So area under the curve between our two values is going to be equal to the probability of getting an outcome between those values, and that corresponds, in this final part of the question, to this total area under the curve. Once again, it's the same in each distribution, because the only thing that's different about these is what units we're counting in on the x-axis. And this part of the question, since we've already gone through the first parts, is the quickest of all. Why? Well, we're interested in finding the total area under the curve between 3 days and 7 days. We already know this area with the horizontal lines, and we already know this area with the diagonal lines. This one's 0.4991, and this one's 0.4082. So if we want to know the total area under the curve, including both of these, all we have to do is add these two numbers together. Because if we add up this shape here and this shape here, we're going to get the area of this total area shape that is the area under the curve between 3 and 7. So to find out this total area, we're going to add 0.4082 and 0.4991. Again, where we're looking at this area and this area, we want to know the total area here under the curve. So we're going to add them together to get our answer. And if we add together 0.4082 and 0.4991, we're going to come up with a final probability of 0.9073. In other words, we have a probability of 0.9073, or we could also state this as a percent, 90.73%, that we're going to have a trial that lasts between 3 days and 7 days. And so we have all our answers here, but to recap this quickly, just go through all these parts here and point out where I got them from and why I got them. We were able to answer this question by drawing everything on the normal distribution and finding the areas under the curve that corresponded to the probabilities we were looking for. So we first found z-scores for our values of interest, which were 3 days and 7 days, and we plotted those on a standard normal distribution. So we were able to say that if we convert everything to z-scores, we're going to have a standard normal distribution that looks like this: mean of 0, standard deviation of 1 every time. And here our trial of 7 days is going to sit at 3.11 as a z-score, and our trial of 3 days is going to sit at negative 1.33 as our z-score. To find the probabilities of getting outcomes within these ranges, we looked at the area under the curve between 4.2 days and 7 days, and we found that by shading in this area with the horizontal lines, and then looking up that area on the z-table. To find our probability of getting a trial that lasts between 3 days and 4.2 days, we figured out that we were looking for this area under the curve between 3 days and 4.2 days that's shaded with diagonal lines, and then we looked up that area by looking up this area on the z-table that corresponds to the shaded diagonal lines. And finally, for our last one, when we were interested in the probability of an outcome lasting between 3 days and 7 days, we were able to find our area under the curve by adding together these two areas that we had already looked up. So we already had numbers for this diagonal lines area and numbers for this horizontal lines area, and so this total area under the curve between our values of interest here, 3 and 7, we could find by adding together our diagonal lines area and our horizontal lines area. And that's how we answer that question. And so on Thursday, we can come back to this as needed. I'll answer any final questions you guys might have, and then we will move on with our lives.